well, this is my blog if you haven't seen it already. And this is the old logo, but I just want to show you the new kind of logo. I haven't put it into the Snapper yet, but you see, this is the low tech version of the Snapper logo, and actually, you know, you have to paste it into SQL Plus in Oracle 11.2 or onwards. So then it will actually generate you something nice. You see what just happened? I'm not sure how fast the screen reacted, but I just pasted this in and it generated me a nice fish with some waves and the sea and so on. And again, I did not spend days putting it together character by character. I actually just used, well, you know, just some functions, and I generated this image, right? And of course, I didn't want to stop here. I just wanted to show you how cool the command line can be, and therefore I have a high-tech version of the logo as well. So again, I gotta paste this in just to make SQL Plus a bit friendlier. And you know, this is the high-tech logo. It looks like a fish, right? Because with Snapper, I mean, Snapper itself is a fish, and with Snapper you can fish for solutions for your, you know, massive range of performance problems and so on. So, and when you take this and paste it into you know, when you use a terminal like Xterm emulator like PuTTY, or on Mac OS or Linux you use something like Terminator, if you paste it into SQL Plus, you will get a different kind of fish. I just pasted it in. So this is another fish in SQL Plus in my terminal. So, you know, read my blog entry if you haven't seen it before. And if you run it multiple times, you will actually see that the waves actually change a bit every time, because I have added a little bit of randomization in it. And again, all of this stuff, I haven't used. I didn't do it manually. I actually just programmatically generated that fish. So and it only took a day. So so it was well worth it when I finally finished it. Anyway, so let's get to more serious business. So Snapper syntax is still sort of backwards compatible. So I haven't you know, changed it. Although let me just run Snapper right now. So this is the old Snapper. So, and usually how you used it, you said like Snapper. Let me go to a different database. You know, I could sample what the single session was doing, or I could sample what all the sessions of a user were doing, for example. And you see this option called Ash. It kind of gives me the top SQL, something like what I can extract from active session history as well. But this Ash here, Snapper does not need any licenses, right? So it doesn't need any diagnostic or tuning pack licenses, because all it does, it just queries $v session. You can look into the script, you'll see how it works, right? So, and again, another option was to add stats as well. And now Snapper will, you know, do this kind of top SQL sampling for me, top weight events and so on. And it also reports me all of the $ses statistics. So it takes 5 seconds. All right. So this is like the aggregate session history here, you know, in the last 5 seconds. But now here we have a lot of metrics, right? So there is a session 233, which belongs to username Zoe, which is the benchmark username. And it just tells me that during this 5 seconds, you know, when we ran Snapper, we have apparently opened 57 cursors. And if you divide it by this 5 seconds, just to normalize it to per second values, I will get, we open 9 cursors per second, right? Or we did, 800 logical reads during this Snapper runtime. And if you normalize it to by second, it will be 100 something logical reads per second. So this is the old Snapper, right? And when we go to the bottom, there is some more. The stat, these metrics come from $ses stat. This is the time model, $ses time model. It's a session level thing. That's really nice. It tells you actually where the time was spent. If we were on CPU so much, for example, were we parsing, were we running SQL or PLSQL? And this is sort of the graphical, whenever we look into time metrics, like wait events or the time model, this is like the graphical layout or graphical representation of this time. So for example, apparently we waited for this wait event for 72% of the time, and it will just show me this sort of bar chart with this information. So I can quickly just skim this information and see wherever the biggest bar is. This is the this is where the time was spent. Okay. So yeah, I had this question. I see that does Snapper require ASH licenses or diagnostics pack or something like that? And the answer is no. The whole reason for writing Snapper was that I wanted a quick way to. I wanted a script which allows me to quickly troubleshoot things without worrying about licenses. It actually Snapper runs on standard edition as well, and Enterprise as well, of course, but it doesn't need any special licenses, so I don't use any of these special views. So I'm actually doing this kind of poor man's ASH. I query $v session manually, 41 times in this 5 seconds this time. And the other principle behind Snapper is, and that's why some of the code is so complex and weird, is that Snapper does not create any objects. So it's just an anonymous PLSQL block, which when you run the script, it will parse this PLSQL block, it will run it, and then it will age out from shared pool. So it doesn't create any temporary tables, it doesn't create any stored object types or anything like that. So that's the principle. So if you have heavy change control the environment, then Snapper doesn't really change anything. Okay, so and back to this. So in addition to the $ses stat and time model, we also have wait events, obviously, and it just tells me what wait events I waited for during this 5 seconds. And obviously I waited for this, apparently whatever application is running here in this session was waiting a lot for this dbms log.sleep. And also something what I added recently, if you have used Snapper before, I actually have changed what you see in this chart. W means wait. So it's just a bit easier for your eyes, I guess. When you look into here, you see a big bar, a long, lengthy bar, which kind of tells time is spent here. I immediately see this is some wait event. This is time model, and when CPU usage is high, it shows at signs, which look a bit like C. And something what I added into the last version of the old Snapper is this. So this is the average wait event duration. So basically, if I start reading it from the left side, you see, apparently this session waited for log file sync only a little. Only 0.1% of the time of that 5 seconds when we ran was spent in log file sync. So I shouldn't really worry about it. But maybe I just still am interested in it. And this is what I added into the old Snapper. So basically this, if you scroll up, you see this column is the number of wait events. Because here I only see the time, 3,000 microseconds, which is 500 microseconds on average, per second. So this is normalized per second. So, and this is the number of waits. So actually, during this 5-second time, we only did apparently 2 commits or waited for this wait event twice. And this is the average. This is the average wait duration. So as we waited twice during this 5 seconds, and in total we consumed about 3 milliseconds of time, therefore the average is 1.6 milliseconds. So it was possible to calculate this kind of stuff, some of these metrics manually, but now it just makes your life a bit easier, right? So you see, it's still the old Snapper. So it's the latest version of the old Snapper. So I'm going to get to the new one in a second. But as I just picked this particular wait event, you see I'm running my laptop, my demo environment is running on an SSD disk. So you see even a single block read, with, likely a random single block read, only takes 700 microseconds on average. So it's a very easy way to kind of quickly see how, what are the wait events for your session. So you see, this is not a system-wide thing. So this is actually for your session. I see how much my particular session was waiting for some event and what was the average duration of the event for that session only. So it's not some system-wide average what StatsPack gives you. So that's nice. And before I go on, I just show you that as I picked the log file sync, this is when you wait for log writer to do the writes. So maybe I want to go further. So if I wonder that, hey, I wonder, let's say the log file sync takes a long time on average, like 20 or 30 milliseconds, then one of the next steps what I would do would be that I can run Snapper on log writer, because log writer is just a session as well. Log writer records wait events and metrics exactly like every other session. So I can either find out what is the log writer seed, or there are some aliases or shortcuts I can use log writer directly. So Snapper will figure out what is the seed. And this is now what log writer is doing. Okay, so and you see log writer itself has done 71, well, apparently has waited 71 times for this log file parallel write event, and on average this event has taken 600 microseconds, right? And and these metrics, these statistics are really useful when wait events themselves are not enough, because I'll show you some examples. But you see, in this particular case, the physical write total I/O requests 71 is exactly the same what the number of times we waited for the log file parallel write. So you see, wait events give us some information about how much we wait for something, right? And how much we wait on average. But these metrics, these $sestat metrics, they give us much more information about what kind of operations Oracle has done. Even things like redo wastage and so on. And from here we see we don't really have much activity. Apparently, when we look into the number of bytes written, the log writer has only written about 28 kilobytes per second. So the throughput of log writer isn't that high, and that's why the log writer itself has been mostly idle. So this is an idle wait event. And the time model, just like there is a thing called DB time for foreground sessions, which tells us how much time this particular session spent servicing our user requests in the database. For background processes, the DB time is actually this, background elapsed time. So how much time this background process spent doing something. So actually, the idle time plus the elapsed time should be 100%. But if you run Snapper only for a few seconds, then there is some measurement error which kicks in. But if I run it Snapper for 100 seconds, then this measurement error and granularity error goes away. Anyway, so this is old Snapper. So I just wanted to show you what you already have. what you already had beforehand as well. And now we go to the new one. So I see a bunch of questions about the internals of Snapper, but I will now show the new Snapper, and then I will go through the questions, because I want to explain some of the internals anyway. So I'm introducing you to the Snapper v4 world, right? So actually, there was one question: that is Snapper safe to run in production? Then Snapper 3, the old Snapper, definitely, because I mean many people use it, and I use it in a lot of places, right? Snapper 4, I don't know. I just updated, finished my updates today, so I would want to perhaps test it a bit more. But the worst that can happen is that it just consumes some resource, right? Snapper only queries $V views, and in a couple of cases X dollars as well, if you actually explicitly enable it. So it doesn't set any diagnostic events, or it doesn't use alter system or anything like that, or it doesn't even enable trace. So in that light, yes, it's safe, right? If you run Snapper 4 and it takes a minute before it returns or something, then just kill it, right? So there is no problem there. But I definitely want to kind of test it a bit more just to optimize it. Anyway, so Snapper 4, the new Snapper that you can download already. It's beta version, and I expect that there are issues. But in all my basic tests, it did work. So Snapper 4 supports RAC as well, and basically it queries $GV views now, and I have to say, thanks to Hans-Peter Sloth here, I'm not sure whether you're in the audience, he actually wrote the first version of RAC aware Snapper, or he converted actually my code, added $GV and added fixes where needed. But I wrote my own version, which is somewhat similar, but I wanted to do it a bit differently. So now I query $GV views, but it's not easy in the sense that when you query $GV views, you're not querying local stuff anymore, and so you have pretty high latency when you query something from another instance. And the latency may be only 10 milliseconds, but if the execution plan goes bad and ends up calling out to the remote node 1,000 times, then it takes a long time. And that's why I actually had to do a fair amount of rewriting just to avoid this kind of looping. Anyway, so RAC support, I'm going to show you that first. And then also, you won't need DBMS lock anymore for sleeping. So, as I said, Snapper doesn't require you to change anything, but it needs to access $V views or $GV views, and it also needed to use DBMS lock, right? But now it doesn't need it. I still use it the old way when I troubleshoot stuff, but maybe when you're a developer, or you definitely want to take a snapshot right before your workload starts and take another snapshot right when it ends. This is when I show you the manual before and after snapshot support and how I did it as well. So that was very interesting, I would say. And it also shows you the useful averages and ratios. Well, in addition to the raw metrics, I'm not just showing you ratios, but actually the raw metrics behind them as well. And there is some more stuff, like I'm actually using timestamps now instead of data type, which makes some numbers more precise when some calculations more precise when you run Snapper only for a couple of seconds. Okay, so let's look into RAC support first. There is a question, is it going to support Exadata? Well, Exadata is RAC running on top of special storage, right? So Snapper can run on the regular RAC and also Exadata RAC. instances. But I have another script or tool called the Exadata Snapper, which is completely different thing, and I'm actually going to introduce it next week. I will announce it hopefully today already. So I'm actually gonna run log into an Exadata box. So so this is it's actually an Exadata box. It's a 2-node rack. So I haven't tested it on bigger rack clusters after my latest changes. So, but it shouldn't matter. So and one a quick word about why I didn't add the rack support before. One reason is that it was harder, of course, than single instance. But another reason is that when I troubleshoot, I usually don't want to see data from all 5 or 8 instances. Right? When I troubleshoot, I'm looking into a specific session or a couple of sessions which are slow, for example, and only if these sessions are slow and their wait events show that they are waiting for something, some locks on an object which are mastered by instance number 4, then I will go and log into the instance number 4 and see what they are doing. But it actually is now more convenient to run queries from on another instance. So Snapper 4. So right now, I didn't call it Snapper because the stable version is still the old one, and the syntax is pretty much the same. I can say Snapper ash 5.1. Let's say this means that to the poor man's ash, run it for 5 seconds, do it only once, and which sessions I want to measure. So let's say I want to see everything what user SOE does. And this actually, when I run it like this, it's actually slower because now I'm not using my local toy database, but it's actually VPN connection to Enkitec in Dallas, right? All right. So this is your first output of Snapper 4. So it's Snapper 4 beta. Use it at your own risk right now, but it shouldn't crash anything and so on. And this is still, when I run Snapper like this, it works the old way, partially because of efficiency reasons as well. So I don't want to always go through the whole cluster when I want to diagnose a local session. Okay, but if I do this, so this number 1 at 1 or at 2, if I do this, then I can actually specify that show me only all these users where the username is Zoe, but only from instance 2, right? Right now I'm logged into instance 1. See, this is demo 1. And I can query what somebody in another instance does. So actually, let me do that once more. So I'm running a script called LotsPios, which does a lot of physical IOs in instance number 2, right? So when I run the Snapper like this, it will look into the local instance number 1. It won't see anything. I mean, it won't see my other crazy user doing I/O there. But when I do this at 2, now it will use the GV views to sample the information from all instances. Not all. The instance number 2. Let's see. So we might have some sort of a bug here. Let me just use the stats as well. So just to get the counters counters too. Let me just try star, because so another option. Well, this is the demo effect, so it all worked, but then I changed something again. So I'm using the star. The star then means all instances, right? So if I don't know into which instance I want to look into, then I see all instances. All right. So I gotta see why the number 1 and 2 didn't work, but basically you see. So this is now the aggregate ash sampling from all the instances. So I actually, if I want to break this down, if I want to get the instance ID column here as well, then I can get it. So I will do that as well. But when you look into this metrics, you see there is session with session ID 983, who is apparently has done something. Well, some metrics have been incremented. It's been idle. I think this is the parallel execution slave who was fulfilling my query. So I actually have to eliminate that. But you see, there was a session number 200. You see, this is 200. So this is my session who has done all the weights here. It has waited for a bunch of different weight events. You see all the averages here. It's been 100% busy, so there is a little bit of granularity error here, and I will get back to that. Apparently, you see there is another session, 1167, with my name, who has been idle all the time, right? So again, it says 98%. So there is some granularity error if I run Snapper only for 5 seconds, but I have something. I have a way to kind of fix it in the future. All right. Oops, I just ran it again. So let me just let me wait it to complete, and I will show you the ash part as well. Just gonna set timing on as well. Then we see some timing info. So it's a bit slower, but partially because I'm running it over VPN from Europe to America. So one thing. So right now I'm just looking into all instances, right? So I can actually. So this is the syntax what I'm adding now. This has been there in Snapper 3 as well. So I can actually pick whatever columns I want to see here myself. And these are the columns in $V session. So you can look into the code and see what columns you can use. But I can actually say inst ID here as well. So show me in which instance there is the most activity. And yeah, I want to see SQL IDs as well. And I want to see, let's say, weight class. So the plus means that basically these 3 fields here, these will be the columns now. So this will be the top, this will be the grouping columns what will be used for showing the top activity. And now in Snapper 4, we have instance ID here as well. All right. So actually, I only see, I think, 6 entries here. I have this variable. So this is for a quick overview. So I'm not showing all the possible SQL IDs what we saw. I'm just showing you the top ones. And you see all of the biggest activity has happened in the instance number 2. So for the user tunnel, right? But if I say, let's say user Zoe, for example, let's pick another one. you see it took longer to run. It actually was 24 seconds as far as SQL Plus saw it, even though I only wanted to sample 5 seconds. So part of that slowness is in the VPN, what I mentioned, and the network latency. But there may well still be some inefficient queries which kind of visit the remote instances too frequently. And I'm going to figure this out. I'm going to fix that anyway. But you see, now we see that when we look into the user SOE, most of the activity is in instance 1. Previously, earlier I showed you how you can use the background process names as well, so you wouldn't have to manually figure out the seed or something like that. Then you see, I just looked into what the local log writer was doing, and you see, this is the seed. This is the seed of the log writer session, and right now I'm showing the instance right like this. You can actually configure it if you look into the script. If you want these to be in separate columns, instance first and then seed, you can specify that as well. But just to save some space right now, I'm using this format. So if I use log writer at star, then I should be able to see what all the log writers in all instances do. Because, log writer is critical for RAC. Sometimes, the global cache waits get longer when log writer is slow and so on. So you see, so this is this instance number 1, this is instance number 2, right? So let's see if, I don't know what I had with the syntax. So if I say at 2, it should only pick me instance number 2. So and this is the syntax. So in general, when now it showed only number 2. So in general, I wanted to have some backwards compatibility. So if you use something like this, that just say use the old snapper syntax, then it still visits the local instance. So it doesn't go through the whole rack cluster, right? Okay. So but when you use at something, this is when it kind of goes to other instances. And if you really want all instances, then you just say at star. If you want only one instance, then you say instance number. If you have something more complex, then then you can actually use this syntax as well. Right? So Snapper, the old Snapper already supports that. It has supported it from the day 1. So this becomes sort of what is passed into an in clause. But of course, the new Snapper now, Snapper 4, it is rack aware. So it's not enough to just list the seed anymore, because multiple different instances may have sessions with the same seed, right? So therefore, you actually have to do this. You select the instance ID and seed from $session. And now this is where you can put any conditions you want, like where username equals tunnel and I don't know, module or program like SQL Plus. Okay, so you don't have to use these static sort of static variables here. Or keywords. You can actually put a query here as well. However, I have to cancel this. So there is one thing. Oops, what happened? I just hit Control C. I ran it and I hit Control C and I got this. So this is nice. My session crashed, and it was. I mean, I was running Snapper 4. But also I was hitting Control C right when I was running a command. So I'm not fully sure whether this is a Snapper issue or not. But I mean, as I think Koskan, you you wish that something went wrong in my demo so I could start troubleshooting it. So let's take a quick detour in there and then get back to Snapper. So I just want to see where it crashed. So we should have something in the trace. But I was hitting Control-C because I wanted to cancel it. I realized something. And I think it had something to do with it. You see. So this error, to me it really had something to do with this Control-C, because when I hit Control-C, then my SQL Blast client will send an urgent packet over TCP, and when my process in the server side receives this urgent packet, it realizes that, hey, somebody is trying to cancel whatever we are running, right? And something has occurred here when trying to handle this cancellation, and I think that's why it crashed. So I'm not going to hit Control-C anymore. So let's see whether it still crashes. So this was a little detour. Please ignore this. Real life, problems happen, and things sometimes go wrong. So my session apparently exited. So let's see how long this runs. For how long? Set timing on. If it doesn't return in a few seconds, then I will just this is interesting. I guess running it twice doesn't fix it. So yeah, please do not use this syntax right now. So apparently I have broken something. So there is quite a lot of, as I mentioned, sampling $GV views is slow, and that's why I had to change quite a lot of things in there. So apparently I've broken it. So anyway, but the simple syntax works like I showed. And of course, the usual use case for Snapper is that you actually, if you know that there is some session which is slow, some report which is slow, then you can just sample this session like this. If you know that it is in instance number 2 and you know it's seed, you'll just say, see what this session in instance number 2 is doing. All right, so that's actually getting more weird now, because it all used to work. As I said, it's a beta tool. So here's my excuse. I maybe didn't change this. Let me just go a different route here for a second. So you know how in Snapper, in the old version, you could put a bunch of session IDs. You could separate them with commas, right? So, but now we don't have only session IDs. Now we actually have instance IDs as well, because it's rack aware. So the new syntax. The new syntax to use if I want to specify a bunch of seeds as a list, I have to arrange them as tuples. So, and I put them into brackets. So let's see what's going on here. 2 and 200. Let's try. So the instance ID goes first when I use this format, and session ID is next. It gets even worse. So I don't know. So I won't waste time on that. So the rec, I apparently have broken something. But basically, when you use user or program, or you can even get all sessions if you like with the all option. This is how you could get measure all the sessions. But I think I wouldn't use stats here. because $V says that has over 600 statistics for every single session, and if you have like 5,000 sessions in your cluster, then retrieving all of them will take time. But I don't think there is any reason to actually get all the detailed session level metrics for every session anyway. So you might actually want to start from the poor man's Ash and identify which sessions or which SQL IDs are consuming the most resource. So for example, I can say here seed as well, seed, SQL ID, event, and so on. So basically, in general, how I use Snapper is that I use the Ash method to find out, which session consumes the most of some weights or CPU, or there's some other way to find out the problem session, like some scheduling engine, and then I use the session ID to drill down into this specific session. So, okay, I actually should use instance ID here as well, because we are looking into we are sampling all of the sessions with this Ash. So I really need to know which session it is, or which instance it is as well. All right, so it's instance 1. But yeah, that's really surprising, but not entirely surprising, but not entirely unexpected. But if I use this, so that's one, then something is broken. Looking into specific seed. So anyway, so I gotta fix that. So this is the price you pay when you do last minute changes. Okay, I think as I am logged into instance, yeah, I gotta see what's going on here. But anyway, so this is from the rack support point of view, the whole syntax-wise, really, there are only 2 things what you need to know about. That now you can actually say at here. If you don't use at, then it will sample the local session. If you use at star, then it will actually go and look for this session on all instances. Or if you use like at 5, then it will only go into instance number 5. And you can use this more special syntax, like maybe not only username, but where program is like SQL plus all instances. You see what I've done here? So even though there is an equality sign, this is just my syntax. It actually uses like internally. So if I put percentages here, it will sample all sessions where the program is SQL plus, and it will do it in all the instances, right? So now it doesn't show all my other sessions, which are some Java code, but all the instances, all the sessions. So it's the single session which is in instance 2, which is doing this work right now. And when I add stats here, then I should see all the sesstat and all the time model numbers as well. And I should use instance ID here as well. I should specify instance ID. So basically, I wanted to show you 2 things. So now there is a syntax, at syntax, which allows you to specify either one instance or all instances. And obviously, when you look into the Ash samples, you might want to break it down by instance ID to see where these weights are happening the most. And previously, the session ID was shown, only session ID was shown here, but now it shows you in which instance it is as well. So by the way, some of this structure and the details and the looks may change, and maybe even the syntax eventually. I'm just I'm practical about it. I'm going to use this Snapper myself more and see what is the more efficient and faster way to use it. And of course, I will announce and document it when I do these changes. So right now I only sampled oops, yeah, I had a typo here. I put the comma here, and Snapper thinks it's the next parameter, but I have to use plus here when I select which columns show up here. Okay, so that's it from the rec. So, as I said, this is a 1 hour session, which may end up taking 2 hours, right? So that's how I roll. But we started 10 minutes late as well, so I don't expect to run over by an hour. So and I'm actually recording this as well. So assuming that the recorder doesn't crash or something, then I will put it online as well. Okay, so this is the rec stuff. So there is one question that this is a. I'm going to show you one more syntax here. So this is one of the reasons why I wanted to make Snapper rec aware. So you can say QC seed or just QC. In other words, the query coordinator. So in old Snapper you could also use it and just say this, and this would sample you all the sessions of a parallel query or parallel DML statement or something where the query coordinator was this, right? And the new Snapper, it probably breaks when I do this right now. Let's see. If I look into, this is not the parallel slave, any parallel query session anyway. Yeah, so there is some work needed here. So this actually, yeah. So let's just try this and. Yeah, because I don't have a parallel query anyway. So this is something which is still broken because I'm modifying this. But that's one of the reasons why I wanted to have it as well. Especially when you have a query where the parallel execution, I guess a scheduler will put 4 slaves on one node and the other 4 slaves in another node, or all slaves are in a different node from the query coordinator, then Snapper will allow you to easily get the metrics from all of them. So right now I think I've broken it again. So sampling GV $views efficiently is actually not easy. So anyway, so that's about rec. I'm gonna go on and I'm gonna leave the questions and answers to the end. All right, so new feature number 2, manual before and after snapshot. So Snapper is sort of partially inspired from Tom Kite's run stats package, right? Basically, Tom Kite had this that you will exec run stats start or something like that. I don't have it installed, of course. Let me just use it like you do something like this, and then you run your select blah blah blah, and then you do exit run stats, end or something like that, and it shows you the metrics. And it actually can calculate the diffs or deltas between 2 different runs as well, but I don't do that yet. So you just have to run Snapper twice right now. But you see the difference is that Snapper historically they only supported this syntax, that run Snapper for 5 seconds or whatever. You could run it for 30 seconds or 60 seconds, and if you wanted, you could do it 10 times, right? So this would have ran for 10 minutes in a row, and 10 would have outputted you 10 snapshots of this session over 1 minute each. Okay, but developers tended to like this, that when you troubleshoot something, it's fine because your session is already stuck perhaps somewhere, and you just take your 5 or 10 second snapshot, right? But if you are a developer perhaps and you're trying to kind of assess that whether this workload or query runs more efficiently or not when I change something, then this syntax would be better, right? Because you don't know in advance how long it's going to run. Okay, so the syntax is gonna be this. Snapper allows you to do that. So let me just pick a, let's see which session I should pick. Well, let me just pick my own session. Let's see how it works. And we might actually have an issue here, but let's see. So Snapper, I can use ash and stats here, right? But if I'm too lazy to type that much, then I can just say all. So it will show me both ash and stats. Okay. And normally it would run Snapper like this. And I'm going to use my own session. Let's see what happens. Let's see whether it breaks here or not now. So let me just run it normally, actually. Well, it hasn't broken yet. It hasn't returned an error message. So local, as long as I don't use the at here, it doesn't break. All right, cool. So this is the old-fashioned usage, for 5 seconds. And you see a bunch of wait events where my session actually has waited for the $GV view slaves, right? The $GV views are queried with parallel slaves, right? It shows a bunch of metrics, okay? And now the new way to do things is this. If I want to take a begin snapshot, I just say begin here. And when I use begin, so this means that we are not going to wait for 5 seconds anymore. These numbers are ignored here, so I just keep them as they, I just keep the usual old values here. In a new version, I actually might remove this syntax and make them separate, options. But basically, when I run begin, it will take a snapshot and it will return the command prompt back to me. I will warn you actually. So there is going to be an error message now. So, but this is that's going to be it's not a bug. It's actually a feature. So you see, bind variable snapper not declared. So actually, I think I have a way how to automatically make it go away in the future. But what I need to do when I want to use the snapshots, I have to run one more command before I run a snapper like this. I will say var. Well, let's use the long syntax. Variable snapper ref cursor. And now it works. I will explain you in a second why is this needed. Okay, so now Snapper took a snapshot, like at the begin snapshot, and it returns control back to me. So now, as I'm measuring my own session here, I need to do something in my own session, right? But I can measure other sessions as well. It doesn't have to be my own, right? So let's do something like this. So let's count star from. I have no idea how long this is going to run, but I can always cancel it with Ctrl+C. So this is a big table. Well, okay, it's finished because it's on Exadata, so that's probably the reason why it was, a few seconds only. Okay, and the second command is end. So now when I have ran my workload, what I want to test, I will run end, and now Snapper takes another snapshot and returns me the deltas. As I'm measuring my own session here, it has some overhead as well, right? My query, my select count query didn't really use parallel query, I think, right? We can check it, right? But some of these metrics shown here are because Snapper itself, did some work as well. Okay, so if you really don't want these overhead metrics, these to poison your data, then you would use some other session, right? So you would have two sessions. In one session you run Snapper begin, then in another session you run your workload, and then you run Snapper end again in your first session. Okay, so what we see here is that in this snapshot we had 58 seconds of time. So basically I spent 58 seconds talking between these snapshots. normally it was dbms lock.sleep, which was sleeping, was idle, occasionally waking up and sampling $V session, right? But when you run a snapper like this with begin and end, then it will take one snapshot and it will be idle, completely idle, giving the prompt back to you, doing nothing until you run end, and I ran snapper end 58 seconds later. And now I see the deltas here. I won't see any of this ash data for the simple reason that if snapper is idle, it cannot sample anything. It cannot sample $V session because it's idle, right? Waiting for my next command. So that's the trade-off. If you want the ash, then you need to run snapper with some seconds instead of begin and end. Okay. If you ask that, hey, what about actually using the real ash, the diagnostics back ash data here? It's possible, but I don't think I'm gonna do that because snapper should be, should not require any extra licenses, and also I think the snapper code is actually, I don't want to make it any more complex. I don't want to add more stuff there, so there will be other scripts for that. But anyway, so now we see the similar output here. So let's take this one, right? So we, during this 58 seconds, we have done 1.5 gigabytes worth of I/O or reads, right? So snapper itself, possibly, I cannot rule it out. It maybe read a block or something, but whatever I ran between the begin and end has done that much of I/O, and so if you run big queries, then the snapper's own overhead is gonna be really small. So, but if you really are changing the difference between 5 and 6 logical I/Os, then you should run snapper in one session and your actual query in another session and measure that. So in 58 seconds, we have done that much bytes worth of I/O. It's 1.5 gigabytes, right? If I select this, it's 1.5 gigabytes. And this column is per second, right? So I have normalized it to this per second value. So I have divided this by 58 seconds and showing it in a bit better format. Okay, and so it's the same snapper output. It's just that you gathered it differently. Okay, so and I'm going to talk to you about these columns later on. And if I want to run another snapshot, I can just do it again. So or I can just say user is tunnel at star. So these let's see if it breaks, but these features should not break each other. I mean these features should all work together. So it certainly worked today morning, but let's see whether it still works. All right, so I took another snapshot. This session in another instance is still doing some work. Let me just do another count star. All right. And let's just say end here. Okay, you see I have listed or snapper shows that session 200 in instance number 2 has generated some metrics, has consumed some CPU time. You see, this is this @ sign is CPU. I use it for CPU because this sign looks a little bit like C, right? It's like a very hardcore extreme C, letter C. So and this is for time model, and this is for weights. So this is session 200. This is session 1067 who was idle. Okay, now I see why I don't see the other guy, because in the other session here is under sys, not tunnel. But anyway, you already see that we managed to capture 2 different sessions from different instances. So the begin and end syntax is also, you know, compatible with any way, you know, any syntax you use here to determine which sessions to catch. So before I go on to the next feature, I will explain why do we need to use the ref cursor. I mean, if you run, you know, if you create the PLSQL package, you can just say, you know, let's say variable 1 is something, whatever it is, and variable 2 is something. Now you start, right? Okay. I'm not going to run it, so obviously it's not going to run. Right? So Snapper, the old Snapper, which uses TBMS log sleep, right? You know, it was very easy for it because I declared some array which was, you know, the before array, and I declared another array which was after array, right? And then I queried the $views, then I slept, and I queried the $views, I calculated the deltas, I printed them out, and I exited. And this was when this PLSQL call ended, right? So this is when all the memory structures were thrown away. Okay, but what I want to do now is this: begin, you know, var1 equals something, end, right? And now I run my user SQL, and now I say begin, you know, print var, let's say var2 equals something, you know, the second snapshot, and now I want to calculate delta equals var2 minus var1, right? This is what I want to do, but sorry, var1. I want to highlight this. But var1 does not really exist here anymore. Because when I run this PLSQL block with the begin and populate something, right? I populate the PLSQL array or some sort of a collection and so on, which is in memory. The moment this PLSQL procedure or block completes, this memory will be thrown away. It's going to be empty. So next time I run this end, you know, snapper end, and try to access var1, it's not there. It's thrown away already. I mean, if you can create the package, you know, a stored procedure, I mean a package, you know, a stored package, right? Then you can create package variables and so on. You populate them. They're going to be there until you exit the session or you reset the package. But remember, Snapper does not require any changes in the database. I cannot create the package. It would make Snapper much less usable in many cases. So I cannot create the package variable. So, and I cannot create the temporary table, you know, so because I don't want to create it. So I was thinking, okay, how would I do that? How would I save the output of this, you know, variable somewhere in the session so I could do whatever I want and later on access it, even though this PLSQL block itself has disappeared. And this is why we need to define this ref cursor. I think I have figured out the way actually how to put it into script so it wouldn't reset it the next time I run it with the end. So maybe you won't need it in Snapper 4.1, but I'm going to show you what I do with it. Oops, this is the old Snapper, so I want the new Snapper. Oops. Oops, this is, you can ignore that. Sorry, you can completely ignore that. This is actually commented out. So you see, I manually opened the ref cursor, right? So earlier when I started, I manually opened the ref cursor. So, and it's called Snapper. Okay, So this is the magic, how I am able to save some data for further use in PLSQL in some other PLSQL block, even though my first PLSQL block finishes and should clean out after itself, should actually throw out all the memory and all the arrays it's using. But basically what I do is that if I'm doing a begin snapshot, these are all old functions somewhat modified, but if I do a begin snapshot, then I will open this ref cursor for this statement. So this is a PLSQL array, or this is some collection. This is where I keep my data, right? So just before exiting Snapper, exiting the begin snapshot, I will open a ref cursor. I only do it if actually I'm using begin or end, because I don't want to always define this ref cursor. Otherwise, the script won't compile or parse properly. But if I use begin and end, then I will, before exiting, I will open a ref cursor for this statement, and this will persist it. So basically what I could actually do is, if I hit var, just to show what variables I have some other variables here as well, bind variables, right? And there is one variable called ref snapper. So I can actually use print. I can use print snapper, but right now there is nothing in there, so it's sort of like an invalid ref cursor. So you see, it doesn't have any any data or proper state, right? But when I say again, let's run snapper. I'm gonna run snapper for my own session, otherwise there will be too much data, I suspect. Okay, so this, if I use begin, it only takes the current statistics from $sesstat and so on, and then it exits. But before that, it actually will open the ref cursor as I showed. And this ref cursor is going to be here until I actually fetch something from it. So I actually can use print statement to fetch from it. Let's say that I don't know why it didn't. Sorry. I say user equals 585. I want C by 585. There is no user like this. I want to see it, so I just use the basic syntax. All right. Now I can say print snapper, right? So this will just fetch. This just fetched from the ref cursor. I actually see, so these are the metric values, and I already see that I should maybe optimize it and not keep the 0 values here at all. But you see, this just opened the ref cursor. And now if I use snapper end, it will probably fail because I already have used this ref cursor. Yeah, you see it says invalid cursor, right? Because I kind of manually went and already used that cursor, right? But this is how I do it. So when I use the begin, I will actually open the cursor, and when I use end, then I will just fetch this from this ref cursor, and I will do a bulk collect back into this array where the data is supposed to be. And I'm actually using you see the DBMS debug varchar2 collection to store the data. So you see the DBMS debug varchar2 collection is just a collection of varchars, right? Because again, I did not want to create my own PLSQL store type or collection type for that. But this DBMS debug one is there in all databases, well, all modern databases anyway. By the way, Snapper 4 doesn't support Oracle 9i anymore, but Snapper 3 still supports it. And right now, Snapper 4 needs Oracle 10.2 onwards, but there is this small fix I need to do to get it to work on 10.1 as well. So anyway, so the ref cursor trick is which allows me to do before and after snapshots without DBMS lock. All right. And before I take more questions, I will look into the last feature as well. I think I need to take a sip of water, so hold on for a couple of seconds. All right, so yeah, I see a bunch of questions. I'm gonna go through them later on. So maybe somebody already wants to leave. So the first two options were more about data collections. More power and more flexibility when collecting data. And I use timestamps now and so on. So that should help to make some calculations more precise and so on. The third one is something which makes Snapper only slightly more intelligent. As I've said a long time, that Snapper actually doesn't solve problems for you. Snapper is not, like a tuning tool in the sense that it doesn't tell you what's wrong. I mean, Snapper only shows you Oracle metrics. It only shows you the snapshot of performance, your last 5 seconds, and it shows you the numbers, what these sessions generated. So Snapper doesn't do the thinking for you, and Snapper doesn't instrument anything. All of these numbers you see, they come from Oracle's existing instrumentation. Snapper 3 and older, they never kind of calculated anything. The only thing what they actually calculated was the delta, the difference between now and 5 seconds ago, or something like that, to see, how much redo I generated in the last 5 seconds, right? So, but now I'm showing some useful averages as well, and some ratios as well. But I'm not just showing some ratios where, like, your buffer cache hit ratio is 80%, and you need to restart your database or whatever. I'm not showing you that. I'm actually showing you the actual metrics, the actual numbers, actual bytes and the number of parses and so on. And in addition to that, I'm just gonna show you some ratios and averages as well, so you wouldn't have to manually calculate so much. All right. So for example, let me just look into, let's use Snapper. Oops, I should have used all instances, but let's see what comes up out of that. Yeah, so it only found my own idle session, so I just wanted to see. Let's look into all instances. And actually, I don't want. Yeah, let's see what the tunnel user shows. I have this table scanning going on there, or this lots POS script. All right. So basically, this is the output. This is what I added. These averages I added in the old Snapper already. So the latest version of Snapper 3 has these averages for wait events. So that was sort of the first step. Okay. So in Snapper 4, I have just added some explanatory stuff here as well. That this average wait duration is is that much for this event. Okay. But let me scroll up. Let's see if I find anything useful here. I will come up with a better example. But one example is a redo size, right? I want to see, from here I see that this session, it's actually not doing any transactions. It's just scanning through some tables. But this session has generated almost 2 kilobytes of redo during the runtime. And if I normalize it to per second, it's 200 bytes per second. Well, it's almost nothing. But this is what I wanted to show. So I only have added a few metrics here right now, but I'm gonna add more. Well, actually, here is a problem. this session didn't commit. So I just want to show you like some useful calculations, very simple calculation that, you know, if I have generated that much of redo, how much per commit have I generated? But in this case, this session has not committed at all, you know, during this 10 seconds, during this 5 seconds. So I'm just showing you we don't know that. So I'm gonna pick a better session. And when I do that, I'm actually gonna show you this. So this is again old Snapper syntax, because sometimes I don't want all of this hash and all the wait events and so on. Sometimes I only want to get the sesstat metrics, for example. See, again, this is all already documented in Snapper. If I want wait events, I will say W as well. If I want the time model, you know, these three are enabled by default. If I don't specify them, you know, I would say this: W for wait, T for time, and S for statistics. Maybe I only want statistics, and I will say S include. S means that only take the sesstat statistics, and S include means that include only statistics which have redo in them, right? Like redo size and stuff like that. So, and you see, I'm looking into all Tanel users here. So basically, right now I'm actually looking into all Tanels, you know, all sessions by Tanel, and but I only want statistics which have redo in them. Let's see, what did I do wrong? Let me just try all here. Gather S, include redo. I may have to add some sort of let me just try this. Because the Zoe, this is the user which has a benchmark and does transactions and so on. So let's see that. Okay, I gotta figure out what was going on, but you know, this is what you get with the beta product. All right, so it found out so let me just scroll up. You see, these are all the different sessions now, right? 391, 589, and so on. And it only included all the redo related metrics, right? So actually, if I only want redo size, then well, I can actually use a regular expression syntax here. Something like this. If I only want redo size, I put the $sign in the end because I don't want these other redos. Perhaps I don't want the breakdown at the moment. Okay, I can use you know, again, if this syntax is new to you, then I recommend you just read through the you know, the documentation in the beginning of the script, and then also you know, the script itself. Okay, I think now I found a little issue here. So basically, what I wanted to show you here is that what is the average redo per commit? Okay, so I didn't use this syntax before, but you see this session has generated 200 kilobytes of redo, which is roughly 39 kilobytes per second. And now I wanted to show you the per commit, but I know what's going on. As I only included this redo size here, now this script doesn't even fetch the number of user commits, so it doesn't see any commits happening. So I'm just going to use the default. I'm going to go back to default. I'm going to use the default syntax right now, just to show how this feature works. And then I'm going to do another demo which shows how you apply this to network round trips and so on. You know, main use case for Snapper, you know, over half of the cases, or maybe like 80–90% of the cases, I pick a single session of interest, right? And I will troubleshoot that. I'm not gonna try to figure out what the problem with a report is using system-wide data. But you know, I will fix these issues. So let's go to redo size. So for this session, again, this session has done about 37 kilobytes of, or has generated 37 kilobytes of redo per second. And this is what I wanted to show you. So there are some metrics where I have already added this useful, I guess, averages or ratios, right? And so, I mean, it doesn't. I'm going to show you the code as well. There is no complex logic there, so it does actually just simple, division and so on, right? So that you wouldn't have to manually calculate so much. And right now, where I haven't added this explicit calculation, I just show you per execution numbers. But I'm gonna, for some of the metrics, I'm gonna change this to something more useful as well. So right now, perhaps I can look into physical I/O requests per second. So per second, we have done 26 I/O requests per second. I mean, this session has done that many I/O requests per second. And it shows that it's roughly 0.3 I/O requests per execution. But again, for some metrics, I'm going to put something more interesting in here. So let's see, what else do we have here? So this is actually why I created this. Bytes sent and received by SQLnet to client. So actually, I need to adjust this formula possibly. But you see, if I want to know the network throughput of a session, as far as Oracle sees that, then this is the metric. This tells me how many bytes were sent from the database to client via SQLnet. Roughly 700 bytes per second. Okay, and this is how many bytes we have received from the client, 1.7 kilobytes. And now I'm using this metric. You see, SQLnet round trips, the number of round trips. Unfortunately, it's both to from clients, so we don't know how many went that way and how many came back. But basically, this allows me to know how many bytes per round trip we are sending. So this is per execution. I haven't added this right just yet, right? So again, this is something which once I add more of these formulas or calculations here, it just makes my life a bit easier. Again, it will save you 5 or 10 seconds when troubleshooting that urgent issue, or maybe something pops out easier that way as well. Because right now, I'm going to show you an example, but you see we only are sending 80 bytes per round trip, so we are not sending too much data back per round trip, and so on. So apparently we don't have much parsing going on, but in the execute count, I show how many executions per parse are done. So I'm not happy to just show some percentage, like 99 executions per a parse or something. Well, not in a percentage, but if parsing is going on, it will actually show you how many executions per parse are done. So if you see only one execution per parse, then it's a good indication that you're not keeping your frequently used cursors open, right? There is another metric called session cursor cache hits, right? We have had 100 session cursor cache hits per second. And here I calculate, it happens to be the same number because we didn't see any soft parses, I think. It tells us how many soft parses were avoided thanks to cursor cache. I'm going to run another script just to show you more about it. And here is another one which tells, okay, here I show a percentage, but we actually see the real number as well. So somewhere up there, up in the output, you see, somewhere up here, we see that the session logical reads is 10,000, right? This session has done 10,000 logical reads during the snapper, snapshot. All right. So we did 10,000 logical reads, but in 2,000 cases, we did not have to do the logical read. We did not have to do a buffer get because we already had that buffer pinned, right? So it's total 12,000 block visits, but 2,000 out of this 12,000 did not require a buffer get because we already had this buffer open and pinned for our session. And this shows then this metric that 17% of buffer gets were avoided thanks to the buffer pin caching or buffer pinning. And again, it's not just the percentage. I mean, I can actually I can scroll up and look into the metrics and see what is the total number of logical IOs and so on. I'm just going to show you one more example. So let's see. Okay, now I'm going to log in. I'm going to log into 10G. Let's see whether anything breaks here. But I tested it on 10G as well, so a bit ago it worked. So I have a session 146, and I will say, set all right. I'm not sure whether you saw what I did. So I just deliberately set array size to 2, and I run some sort of a query. And now I might wonder, why is this query so slow, right? And when I run snapper for ash51, let's say that this is some sort of a report or batch job, which seems to be really slow. Let's see, 146. Okay, so I added the stats as well. I need to see what's going on. But you see, if I look only into the ash numbers, you see it in this 5 seconds it's sampled 47 times, and you see it's not very active. It's only 6% of the response time it has been active. At least that's what it says. And when you look into DB time, DB time is how much time your session was actually working for you. And you see, DB time also kind of confirms something similar, that it's a bit different. It comes from a different source. It says that 4% of the time. This session was only active 4% of the time. So it actually was idle 96% of time. So this is wrong. I couldn't fix it. I couldn't figure it out properly by now. But DB time will have this extra, a bit more complex calculation, which tells you if there is any unaccounted time which is lost thanks to CPU scheduling or instrumentation problems and bugs and so on. But it doesn't work at the moment. But what I wanted to show you is this. We are idle, right? We are spending plenty of time, sending data we are spending a little time sending data to the client. But if I look into the wait events, there is one wait event which is an idle wait event. That's why the ash data doesn't show that. Idle wait event is where your session is idle. It's not actually working. It's waiting for the next command from the client. And you see, over 90% of time is actually, this session was idle. We already know it from the DB time, right? It was idle, waiting for next command from the client. Waiting for the next fetch, maybe. Waiting for the next, parse, execute, whatever, right? So why was it so idle? So whenever I see that somebody's idle a lot of time, the next question is, what I want to know is, where does it come from? Are we idle for a long time in a row, or are we idle a little bit and many, many times in a row? Well, we can use the average wait. That's one way. this works in Snapper 3 as well, right? So because I added averages. And we see that on average, we wait for 700 microseconds only. So in this last 5 seconds, we actually have had 1,000 waits of 700 something microseconds. And why? Well, that must mean that we send something back to the client and then we wait for the next command, next fetch and so on. And I'm wondering how much do we send back to the client? So I can look into the bytes sent. And this is what I wanted to show. I can look into these numbers and I will see that this particular session sends back about 300 kilobytes of data per second, right? But also I calculate the round trips. Well, I know the total bytes and I know the round trips, so I can roughly calculate the average. And you see, we are sending back only 258 bytes per round trip. So now if this is a query, it returned 300,000 rows. So if this is a query which is supposed to return 1 million rows for some analytics engine or whatever, or copy data somewhere and so on, well, it should not return only 200 bytes per round trip. It should return more. That's why I set the array size to a small value just to show that point. So I can set the array size to something much bigger and run the query again. And run Snapper again as well. Okay. So let me just run it once more. I don't know why the bytes. The bytes per second has gone down. So that's actually interesting because it used to be 300 kilobytes. But so that's actually kind of unexpected. But it can have something to do with this. This guy has to scroll the output. There may be application think time here. It has to spool it into a file as well. So if I run it in a script, it probably is not throttled. But you see, now it's 400 kilobytes per round trip. Right? So it used to be 280 bytes per round trip. Now it's a half a meg per round trip. So I'm gonna create more of these metrics like that. So that in addition to the raw metrics, there will be something, what you can just take a look at, and so you wouldn't have to manually calculate these things, right? And I'm gonna fix this, so this is gonna be useful as well to find out the unaccounted time. Due to all the bugs and scheduling latency and CPU starvation and stuff like that. I'm going to run a script called lots hard parses that I use in my demos as well and in training and so on. And it does a lot of hard parses. It parses random statements. Right, so this script did, you see, hard parses. It did about 2,980, almost 3,000 hard parses per second, right? So it did that many soft parses, and all of them ended up doing a hard parse as well, because the cursor, what we wanted, was not in cache. And then we have executed this query as well. And you see, this is I have added some metrics here as well. So right now they're very, very simple, just one. So that we have 1 hard parse per execution. So in this session, during the last 5 seconds, every query which was executed was also first hard parsed. So that's not really good for optimizing. Or that's not good for OLTP and frequently executed queries. So I'm going to kill it, and I'm going to use another script called lots of soft parses. which only parses one query and runs it again and again. Okay, so it has executed something 66,000 times. You see how much the throughput has increased. Instead of 2,000 or 3,000, now we don't do a hard parse. And actually, it's not doing any parses at all because it has cached the cursor. And I think this is the PLSQL. It's a PLSQL loop, what I'm using. It actually keeps the cursor open, so we don't see any of a cursor related or parse related metrics here. This is because session cached cursors is set as well, and PLSQL engine picks up this number and uses it for itself as well. That's why I have a lot soft parses too, which again you can download all the scripts, which sets the session cached cursors to 0, like in the old times. So, and let's see what happens now. Okay, you see, okay, so these are really small numbers. 0.69 in times 10 in the power minus 3. So it's a parse times CPU, but let's see. Right. So we have 24,000 soft parses, but we cannot calculate how many hard parses happened because during this last 5 seconds no hard parses happened. So which is a good thing, right? So we didn't see any hard parses happening. That's why we cannot calculate this. All right. So this is a measurement error. So this is because some of these metrics, when you have a long-running PLSQL procedure or query, are updated every 5 seconds. So if I actually run Snapper for 30 seconds in a row, then these measurement errors, where sometimes it's over 100%, sometimes it's under, they will kind of diminish and then they will kind of fade away. So I'll show you that as well. But you see, the time model metrics are very useful as well. Again, Snapper 3 also has that. You see, they're very useful because they tell you more. They're not about the wait events. Wait events tell you one thing, but this is like a different angle to the same data. No, come on. So this session was idle. I just ran it again. The time model is like a different angle to the same data. So, ignoring that it shows more than 100%. So DB time is, the reference point, sort of. We have to compare everything to the DB time, right? And we see that if DB time was 138%, then 35%, then the PLSQL time was roughly 38%, and the parsing time was 23%. So, but this is actually gets a bit more complicated. Why the execute time is also equal to the DB time. So when you call out SQL from PLSQL and vice versa in a tight loop, it sometimes happens. But anyway, so I don't want to go to these extreme cases. I just want to show you a generic use of Snapper. But time model is something to keep an eye on, because you don't have to look into these numbers at how many times we did the hard parse. You can actually start from looking into how much time, how many seconds we actually spent doing my hard parsing. If it was like 0.1% of the response time, then I don't care that much. Okay. So you see, I ran Snapper with 30 seconds now. And now this measurement or this granularity error, which is sort of dependent on this 5-second update step, it kind of goes away. And if I use I can show you something else, but if I use 100 seconds, then I think it should get very close to 100% if the session actually is constantly active then. All right, I'm going to show you the code for the averages. So there is a function called getUsefulAverage. So when I print out these metrics, then for every metric, I will check whether this particular metric has a sort of a useful average associated with it. Okay, and I only have put these here just to show you, what's coming. And over time, I'm gonna, revise it probably, but I definitely will add much more here. And basically, what I say here is that whenever the metric name is bytes sent to the SQLnet via client, then I will divide it by the SQLnet round trips to and from client, right? So I may need to adjust this algorithm a bit, so because we know how many bytes were sent and how many bytes were received, but the round trips figure is both ways put together. So there's some limitation here. And when the metric is redo size, then in the end of this output, I will show redo size divided by user commits, and so on. And the buffer is pinned count is a bit different. It's not just basic division. I actually have to take the buffer is pinned count metric, and I will divide it by the same metric plus the session logical reads. And actually, I see I thought I need to add brackets here, but I actually have the brackets needed here already, so that's fine. So this is where I will kind of add some very basic intelligence into Snapper, but it still won't tell you what your problem is. I mean, it still won't fix your problems itself, but it will allow you to extract numbers easier from Oracle, so you could decide. So I actually have called Snapper in the title the most advanced Oracle performance troubleshooting script out there, or something like that. And the emphasis is on the word script, actually. Because Snapper is an awesome script, but it's not as advanced as ADDM, for example. So, ADDM actually has some pretty hardcore logic in it for actually recommending you some solutions in plain English and so on. And Snapper is never going to be something like that, right? But Snapper is, Snapper is what you use when ADDM doesn't help you. You run ADDM, sometimes it helps, sometimes it doesn't. And when it doesn't, then you have to use your own brain again and look at numbers, right, yourself. And Snapper allows you to extract this easily. Okay. So I'm trying to figure out this unaccounted time as well to diagnose like instrumentation bugs. And this actually is pretty lengthy and ugly code, and it is wrong right now. So the DB time comment. So, but anyway, Snapper is gonna continue to evolve. Okay, so that's pretty much all what I wanted to show right now. So these are the major features. And I'm going to go through some questions now. So, well, as we started 10 minutes later, let's see. I'm going to go on for another 10 minutes and then I'm going to finish. Because, when the new Snapper, when I released the final version, then or the release candidate, then I will write proper documentation as well. And I'm actually going to use the new Snapper in my training as well, which starts in 1.5 weeks, because I actually noticed that in the training sometimes when I explain things to people, I manually calculated the numbers and so on, and it may actually have ended up too complex, too many little details. So now it's just much easier to show some averages and stuff like that. Okay, so. There are a lot of questions here. So in case people drop out, I'm gonna address the questions in a minute, but I'm just gonna I want to announce a couple of things as well. So So I will announce three things. So if you use Exadata, then I want to tell you two things. That in August 5th and 6th, again, this year as well, there is Enkitec Extreme Exadata Expo happening again, and it's almost exclusively Exadata related. So it's pretty much it's all Exadata plus a couple of sessions about the developments of big data in enterprise. And you can actually submit your abstracts as well if you already are an Exadata DBA or developer. So that's one thing. So keep in mind enkitec.com/E4. Another one is that I'm going to have another session like this next Thursday, but it is going to be about Exadata Snapper. So let me see if I have some output. I'm going to show you a slide of that. So you would see what the Exadata Snapper looks like. It actually is a different tool, and they kind of complement each other. So conferences, UKWG. So Exadata Snapper actually does create objects, right? So it's a different tool with different aim, but I'm just going to use this. So basically, so this is the basic output. There is advanced output as well for Exadata troubleshooting, but basically this is a basic output. What you can see. Basically, you can run Exadata snapshots or snapshots on sessions as well on Exadata. It stores the data in some tables, and then later on you can run diffs, like reports on this data, just like AWR, but it's session level. And it's Exadata specific. You see, it shows you what this session was doing, and the units are in megabytes. For example, it tells me that this session has done 2 gigabytes worth of physical reads, but actually the storage index is saved 1 gigabyte. Therefore, we actually had to, from real disks, we only had to read 1 gigabyte. And we only had to process 1 gigabyte worth of blocks inside the storage cells. And this is another example which allows me to kind of calculate how much writes we actually had, thanks to ASM mirroring and so on. So I'm not going to spend more time on that. So next Thursday, I think the same hour of the day, I'm going to announce this in my blog as well. So if you are using Exadata or just interested, then you can show up. So this is the basic output, but there is also the advanced output, which actually kind of can peek inside what happened in the storage cells and whether you hit any problems and so on. So this is the second announcement. And before I go and answer questions, so I just want to mention the last thing as well. Well, I do training as well. Likely these troubleshooting and SQL tuning classes are the only ones this year, because I'm kind of moving towards the Exadata more and just don't have that much time for the training anymore. But if you just click on any of these, you will see the listing, and these are online classes. Anyway, so back to the questions. Let's see if some people are still online. Yep, some people are still online, so this is good. And I'm just gonna start from the end, I guess, because it's more recent. So Sergey asked whether a snapper is colored, and no. So I only on that slide I changed the color, but I have thought about it. But it's not a very high priority feature. But I will put this colored fish logo in there somewhere, so at least there will be some color. Pavan, I think I'm going to skip your questions you sent to my blog. I still remember this right now because these are more about internals. So I'll just go through some more basic questions first. And if I don't have time today, then I will just answer in my blog. And if I don't, just keep reminding me. Okay. So, Koskan asked whether I have any plans to backport the useful averages to Snapper version 3, and no. It is actually possible. I mean, there is you know, there is actually nothing which wouldn't which would stop you. So it's because it's not tightly coupled with the GV$ views. So it is possible, and just if you want to do it yourself, and if it works, then I can publish it. But what I plan to do is rather, I plan to spend my time on finalizing and fixing and optimizing the Snapper 4, so you wouldn't even want to use Snapper 3 anymore. I guess when you have Oracle 9i somewhere, then you might want to use it, but I don't care anymore about 9i. Occasionally I still see it, but I can handle it with the old Snapper. Leighton has asked whether Snapper works with SQL Developer, and the answer is yes. But it's not published yet. So, or I haven't published it. I now have forgotten who was that who made the little fix. So basically, let's put it that way. Yes, Snapper has worked with SQL Developer after a couple of small fixes, and I think give me a week and it will work, and I will write an article about it because I like SQL Developer more and more every day. So yep. And Sergey asked about HTML output. Actually, I have had that in mind as well. So that would go together with SQL Developer, actually. So one day, I would want to make Snapper, like a report in SQL Developer. So when you run it, you can get the output, and why not HTML? Okay. So what else? So Cyan, I'm not sure whether I say the name correctly, mentioned that SQL trace, the auto trace stat would be different. I'm not sure exactly what you mean, but basically how auto trace works, it actually creates a new session pretty much in your process. So you will have two sessions in your process at the moment, and it uses the second session for running the queries against $V views, right? So it doesn't affect your first session's metrics. So, but again, autotrace, it only reports you a few, like 10 metrics only. So when I'm optimizing something very short running, something which uses 20 logical IOs or something like that, then I usually have two sessions. One session where I run the actual, query, and the second session is where I run Snapper to monitor the first one. So then I don't mix up the metrics. Okay, so yes, arrays. So Cyan mentioned that this example, this mention about auto trace was about array size when I set it to 2. Yes, auto trace would have shown that as well, that how many bytes were sent. Okay. So let me go back a bit. So Paul, so I'm not gonna show them how to use Snapper to pinpoint what session is causing a problem. So at the moment, so that would be a topic for another session or the training. So right now, I just wanted to show you the new features of the Snapper. But basically, there are different scenarios, right? So when your CPU utilization is too high at 100%, right, you can use Snapper with ASH option just to see which SQL ID is the top one, just like you would do it from the regular ASH. When your problem is that the redo generation is too high, you would use Snapper with the redo metrics like I used before. I think so, just to see which session generates the most most redo, and so on. So there are so many different cases, and I didn't mean to show it in this session. Okay, but let's see if there are any more snapper related. So Mustafa asked, what is the legend for the graph? Which is a good question. So basically, what does this mean? I understand, right? So and also, what do these things mean? So in Snapper earlier versions of 3, I just used the same character. I used the @ everywhere, right? So the character, but now just I use different character. But whenever I list wait events, the character is always going to be W, right? And whenever I list db time, then the character is always going to be hash, except when it's CPU. Then I show @ which kind of looks a little bit like C, which is very weird C. But it actually is in my blog entry. Yeah, if you just scroll down, so there is one of the blog entries where I announce Snapper 3.6 or something like that, and the legend is there. But I only use these 3 different characters, and they really don't mean anything. So they all used to be the same character, but now I just use different character depending on which section I'm printing here. So just you see that, hey, this long thing is a wait, and also what does 100% mean, right? So again, there is this granularity error, or this, I don't know, measurement error when I run Snapper for 5 seconds only. But what this means is 100% of time. You see, when I run Snapper, I say for how long to run. So I know how long I ran, how long the Snapper was running, right? So I know what is the total time in this measurement. I know that I should have 5 seconds. So 5 seconds is that 100%, right? So, and if thanks to some error or some issue, a bigger number is reported, I'm not going to draw the graph out here. I'm just going to max it out at this 5 seconds. So how I read it is that, for example, SQL execution took 6.8%. 6.8% of what? Well, of this 5 seconds. So if I run Snapper for 10 minutes in a row, then this 100% would mean 10 minutes, right? But this is just a visual way, so I can quickly skim through this info and see wherever the biggest bars are. This is where I should look into first. So let me go back up. So Olivier asked about earlier, when I ran Snapper with the begin and end, right? So like this, right? So is it possible to compare, just like Tom Kite's run stats has, Tom Kite's run stats also has begin, middle, and end. So I can run 2 different queries, or with a little change, right? And then it will actually compare It will show me the difference between these two runs, right? So Snapper right now does not have it. So right now I can just do begin and end. And perhaps, if I really want to use Snapper for this for some reason, you see it's comma separated, right? So you can load it into Excel really easily, okay? So, but I already have started this syntax. So what I want to do is something like this. I will say begin is like test1. I think it even takes the syntax, but it doesn't do anything yet right now. So begin is test1. I do whatever I want, and then I will say end is test1. And I think right now it just prints the output already, but basically you will be able to have different snapshots here. Right now you cannot, but I want to have like different snapshots. So you have test1, test2, test3, or whatever, with the index, without the index. And I would still keep this in a memory array somewhere. And then you can run diff, perhaps diff test1, test2, or something like that. But I'm first gonna make Snapper 4 stable, with the features it has right now before I add anything more. Let's see what else. So Marcus asked, I think I already explained it, where the begin snapshot data is kept. It's a ref cursor. Yeah, so I think I got to the beginning of the questions. Let's see if there is anything else. Sergey asked that whether I can use hash options with the begin and end. So there is this hash1, hash2. If you look into the code and the documentation in the script to see what they mean, you can actually report different metrics. Let's actually do that. Hash3, like a different breakdown of this hash. I'm almost done. I'm gonna finish in a moment. So you can actually report multiple different, up to 4 different breakdowns. It's defined in the script. Well, it didn't work right now, so I'm gonna ignore it. So maybe I need to add the stats here as well. But when you use begin and end, then there is no hash here, because when you use begin and end, then between that, this session is idle. It's doing nothing. It cannot sample this hash data. However, you see, this example is done with the end, begin and end, right? Even though you don't have the hash data, then you still have the wait events, because these wait events. That's why there are 2 sections. When you have that section, when you have the data in the bottom here, it's the poor man's hash, which is querying $v session every now and then, if you use the DBMS lock sleep approach, right? But when you use begin and end, you still can use this. It at least gives you some overview about the wait events, because this doesn't come from sampling $v session. It comes from querying $v session event. And Oracle keeps session event up to date itself. I don't have to sample it. So it's also a bunch of counters there for every wait event. And that's how I can, get, average wait events pretty well. You see, SQLnet message to client is actually a bogus wait event. It doesn't really do a system call. So on average, it takes only 2.5 microseconds, right? So Ray asked that can I use sort of a snap ID and end snap ID. So can I use snap IDs? Well, this is what we'll have it doesn't work right now. I started, so the sort of, I already checked for the value of this parameter, but I don't really store different snapshots right now. But I plan to have it. But again, so this will be still like a ad hoc troubleshooting tool and the developer tool for checking a query every now and then, or quickly checking some metrics for a query. I would still say that as a long-term strategy for troubleshooting, whenever you see repeated problems, you should find a way how to kind of build something into database for diagnosing these issues. In other words, Oracle's active session history is a really awesome starting point. So, especially if the problem happened in past, right? So with Snapper, unless you run it in tracing mode, which is also possible, then the problem has to be ongoing if you want to troubleshoot it. Okay, so I think I gotta finish. There will be once I've kind of finally released Snapper and the final version of 4.0, which is not beta anymore, then I will write something as well. So you wouldn't have to listen through the 2 hours every time you want to recall something. So again, I put it into chat. I will just put it once more. I think I'm not going to announce it in my blog yet, because I want to chat, because I want to first fix the issues, right? And then I will announce it in the blog. But when I do, I will kind of repeat, the new features and the syntax for them there as well. And maybe someday I will come up with a proper white paper as well. But yeah, if you want to learn more about Snapper syntax, just open up the script. I haven't added the new syntax there yet, but this article that I just put into chat here, it's a pretty thorough overview. And again, if you haven't used Snapper before, then maybe you want to use Snapper 3 first, because it doesn't have the bugs. It actually is very solid, and it works really without problems. So I've been using it for years and years, and many other as well. And Snapper 4 will get there as well in matter of a couple of weeks, I would say. Okay, so if you have any more questions, drop me an email. You can get my email from my blog. And Pavan, we ran out of time, so I will answer this what I can in the blog entry. So my contact is here. Just go to my blog. And yeah, that is all. Let me know if you have any problems, and if you actually managed to solve some problem with Snapper, which you weren't able to do before, then let me know. This is a really good motivation to hear if it's helpful for others as well. And check out my training if you actually want to see how to use these kind of tools for solving real problems. So thanks very much, and see you next week if you choose to show up for the Exadata Snapper session. Okay, thank you and bye.